Shimla says, Shimla people says what? क्या कहते हैं? What they say? Let me see it. So, good evening. Okay, good evening. So our this live streaming is also started in front of you. You can see it properly. It's working there. Okay. And here we see. So those who people feel network issues, you can side by side watch on the YouTube also. I mean, for rest of the students. Yes. Good evening, Mansa students. Um, I have clicked on the slideshow here. Hold on. Okay. So we're going to start with the prism now. Okay, as you already told, it's time for the prism. I request all of you students be very much focused here in the class now. Okay. I'll be very slow, no issues, but you have to understand. And whenever I say reply, you must reply so that I can send it to next slide. I can turn it to next slide. Okay. See, so learning objectives are this. Contents of today's class. Okay. So first we'll go through refraction shown by this prism. Then we'll go through dispersion of light by prism. Then we'll see a rainbow formation. Then at the end, scattering of light. So students, this all thing is included in this prism portion, by the way. Okay, prism plus some natural phenomena. This is all included in prism plus some natural phenomenon. Okay, let us start now. So what you're able to see on the screen, this is what? This is white light. This is white light. And this is prism. See, I'm telling some difference between prism and other objects. Okay, here. See, if you take a glass slab, by the way, you know, if the light is entering normal, it will pass normal. Okay, if you turn this glass slab like this, and if you incident a light at a particular direction, it will do some deviation because it's from rarer to denser medium, and then again it will come out parallel. So this emergent ray and this incident ray here is parallel. Remember this thing, students. We know this thing, that this incident ray and this outcoming emergent ray are both parallel, but there is a lateral shift T in both of them. We know this thing. It's 1 upon, like, you know the values. How much thickness, lateral shift is how much? T upon, what was this? 1 minus 1 upon mu. I hope you remembered it. Anna? There was some lateral shifting by the slab. So T equals 1 minus U for other thing. It was cos R thing. Okay. So whatever, there will be shift, lateral shift. Matlab, if incident rays like this, emergent will be shifted parallelly to it, but parallel will be. See, so there is a not lot of deviations in the slab in both of these cases. You know? But if you take the case of prism in front of you, this case, you know? So you can see this white light is dispersed by this prism into 7 colors in front of you, which are like this. Okay. So, and what's a prism is? Prism is some, the glass material, or if you take 2 glass plates, okay, rectangular kind of, and if you join them like this, and at the end, if you cover it like a base, and also inside material is full complete of the glass. So there's such a material is prism, and it shows you the deviation basically of the light rays properly. And one of the best sign of this prism is this. If you want to see that only the prism materials always show you dispersion. Dispersion means what? White light converted into its 7 colors. Okay? White light into 7 colors. Okay, in the lower classes, we did something. No, we took a cardboard like this circular, and we have drawn like this with pencil kind of figures. Okay, a wheel, and then we colored and we colored these gaps with different colors, and we played with this. We tried to roll it like this back from one hand here, from one hand here, and we were rolling this. So we have seen what that this all the colors mashed up, they mixed, and we were able to see what only the white color. We've seen this thing, no? You know? Yes. So this was a little bit of the prism. I mean, see, if the white light is going like this, I'll show you in the next slide now. Ready? So I'm going to show you this on the next slide. So let us see more in depth of the refraction through a prism. Let us not talk about the angle of deviation. What is it? Don't worry, this is a prism in front sides here. Complete of the glass material that is having refractive index, you can call it as like 3/2 because glass ka refractive index is 3/2, 1.5. है ना? Glass ka refractive index is 3.2, 1.5. And this angle, students, remember it is this A angle is known as apex angle of the prism, or you will call it as angle of prism, or you can call it as angle of prism. Okay. Manoj, please mute yourself. Mansa, please mute yourself. JNV Mansa students. And Manoj, please. Okay, Manoj, I'm muted. Mansa, please mute yourself. JNV Mansa students. Cool. This angle is known as angle of prism or apex angle. Suppose a ray is incident on this prism like this. This is a ray incident ray. This is known as what? Incident ray. Okay. And this is a normal drawn to this first surface. This is what first surface. This is a normal drawn to this first surface. An incident ray passes after reflection. This is what? When a ray is passing from first, this is air medium. This medium is what? Air medium. From air to this glass material, it passes. It will show what? You can see here. It is showing a deviation like this. It is showing you deviation like this. Hai na? Why? So this is the angle which the incident ray is making with the normal. Okay. And this is the angle which this refracted ray is making with the normal to it. No, this is not a normal. Hold on. My mistake, student. This is the angle which this refracted ray is making with this normal same. This is R1, I will call. You can see it. Okay. So this we can say is what? It's R1. Similarly, when this ray will go like this and when it will come out like emergent ray, so again it will make an angle like this. This angle is known as emergent angle. Okay. And these are the internal angles. So when the ray is coming from air to this denser medium, it is bending towards the normal. So here angle of I is greater than the R1 angle. And when the ray this is going outside from a denser medium to a rarer medium, I'll say it is bending away from the normal. So here E is greater than this R2. Okay. Now we will find out the angle of deviation. But what is this angle of deviation is? If you extend this emergent ray back like this, okay, see here. If you extend it back, see this. If you extend it back, you will get what? Angle of deviation. This was the incident ray. You know it. This is the emergent ray. This is the angle of deviation. So I can define angle of deviation as what? I'll say angle of deviation is defined that by how much angle the incident ray is turned and emerges as emergent ray, turned from where? Turned from its initial direction. That is del angle. Or you can say like this, students. The angle which emergent ray makes with incident ray direction. Angle which the emergent ray makes with the incident ray direction. That is angle del. Now let us see the mathematics. What is the value of del? See, we will not go into the depths of this. Just we need the formula. So we'll see an overview definition, derivation. See, if you see here, it will be given on the PDFs, okay? Yes. Remember this thing, that angle of prism here is equals to this R1, R2, because we know internal angle of the triangle is equals to sum of the external opposite angles. You know? So once we get this somehow, after this, we'll say angle of deviation which we are getting. This. So remember this formula, direct, okay? No need of getting confused in these things. This is just for your conceptual clarity. If you want, anybody want a derivation, so he or she can see on the PDF there, okay? So from this, you get the angle of deviation as this. This is for emergent, this is what incident angle. This is what emergent angle. Angle which the emergent ray which is coming outside of this prism makes with the normal emergent angle. This is what our apex angle of prism. This is our apex angle of prism here. Okay, so this is the del value which you're getting. This shows the deviation angles. Okay, now let us analyze the graph. Suppose a ray is going inside and deviating and coming out. This is the picture. This formula we already know, that angle of deviation is known as, is equals to what? 1 plus E minus A. Is it fine? Yes. So now if we focus here, students, this graph, if you analyze this graph, see, at this point, on the x-axis, it's cutting here a particular I angle and particular E dash angle. Right? So we say, you can see like this, that for one y coordinate, there are two x coordinates, x1 and x2. इसके लिए for one y coordinate, that is 50 degree. And what is this y axis? It is angle of deviation rated, and it is angle of incidence. So we can say there are two angles, and it looks like two angles of incidence, but actually they are the same. I mean, if you pass the ray like this, I, it will come out and it will show E value. Okay. And again, if you pass a ray, from opposite side, see, this is for I angle, that is this x1, and E will be coming same. Okay, but if you keep that E angle and pass a ray from this side, again it will show you the same picture. See, from that side, E and I. So this is same here. Okay, I mean, if you start from here, it will give you E value there. If you start with angle of incidence as E, it will give you I as E here. So these both are same, like vice versa. So for both of these, you're getting the same angle, 50 degree of deviation. Okay, from this graph we can find this thing. Okay, but there is a particular angle. Okay. But there is a particular value minima where this I and E are both same. Okay, so for such angles, I mean, where if there is a prism and we pass a ray, for this I and E are both same values. They're having the same values. Okay. So for such a case, we'll say angle of deviation will be minimum. And it will be like this key, the ray which will be passing inside the prism will be parallel to the base, such that emergent angle will be equals to the I angle. Okay. So remember this thing. Now we need to find that angle minimum deviation and also that I equals to E, which for which this condition will be visible. That is angle of deviation minimum. Okay. So please reply in the chat box. Is up to this, is it clear? Please students reply in the chat box. Up to this, is it clear? So we can proceed next. Reply it, please proceed next. I'll proceed. Okay, so Jinvi Shimla student says clear. What about other students? Okay, fine, very good. Great, great students. Excellent, very good. बहुत बढ़िया. Jinvi Udhampur says clear. Good. Now let us find minimum angle of deviation. This is our prism, very favorite prism. Apex angle A. Ray is going inside. So I told you, if I is equals to E, so it will look like this. Okay. So ray will be inside in the prism, the ray will be parallel to the base and it will emerge as E angle. Okay. So for this condition, I will say I angle is equals to E angle. Incident angle is equals to emergent angle, and inside picture will be this, that this ray will be parallel to the base. Okay. And if I apply the theorem, I'll say here somehow I'll get A equals to R1 plus R2. And remember this thing, whenever there is, see if I extend it back, this will be the angle of deviation, which will be basically minimum. Okay, it's more back. I'll extend a little bit. This will be angle of deviation here. That is a del. This is just we have to keep minimum. And for minimum, this ray inside will be parallel to the base. I will be equals to E, one more condition. And also remember this R1, which is basically the refracted angle of the first ray incident. And this is the incidence angle of the second emergent ray. And this both will become same. Okay. And then you have to put the value. We can say then, okay, I will show you the printed version here. See, at the minimum angle deviation, that is DM, I have changed the symbol. We know the common formula, it is I plus E minus angle of prism. Okay. So now I will change, if I want the minimum, I am using this symbol DM. Okay. So remember this thing. We know I is equals to E, this is the condition we have to follow. Okay, for this minimum angle deviation. It will show actually. So it shows here refracted ray inside the prism. Will show you that refracted ray inside the prism becomes parallel to the base. Okay, so whenever this kind of picture you see, directly you can confirm it is minimum angle of deviation shown by the emergent ray. I mean, or incident which is turned in that with that angle as coming out. So also this condition will be followed. That is, we'll say R1 is equals to R2 equals to R. Next, if we focus on this formula, if I put here this first condition, that is I equals to E, okay, then what we get? We get like this, 2I minus A, because I equals to E will be 2I. Then from this, you will do some simplification. You will get I as this students. This is the I value. Okay. Now also we know A is equals to R1 plus R2. If I keep this R1, R2 same like this, some R, see on the right hand side, most right hand top corner. If I keep R1 equals to R2, R, if I put it here, this will be 2R. And this shows you here. Okay, now let me, if I'm putting this A equals to 2R here. R equals to A by 2 here. Okay. So see, let us see the next slide. So this is the condition we have already seen. Right? It was due to that. dm is equals to 2I minus A. Radius of curvature is, this is not radius of curvature. This is R, that is reflecting angle. So Snell's law, we know this now. Okay. So now I'll put the Snell's law. I mean, N1 is for reflecting medium outside, N2 is for inside, N1 against surrounding medium outside. Sin I is of this, sin R1 is for this. Okay. So I'll put here the values like this, students. This will be the value N21 minus A. So this is our final formula. Okay. I'll apply the Snell's law. I put here I value, which I know from this. I'll modify it and put R is R here. We know it's equals to A by 2. So when you will use some approximations, you'll get angle of deviation, because see, we know sine theta, when theta is approximated very, very small, we say it's approximately equals to theta 1. So same, this angle will be approximately equals to this. This will be equals to this. This is equals to refractive index. So when you will simplify it, you get the minimum angle of deviation as refractive index of the glassy material with respect to the external surrounding refractive index minus 1 into angle of prism. So this is your formula here, students. This is our formula of minimum angle of deviation. Up to here, is it clear, students? First reply, then we'll proceed. First reply, students, then we'll proceed. This is the formula of the minimum angle of deviation shown by a ray which is incident in a prism. Very good, very good. Genevieve Roper student says yes. Cool. Manoj says okay, let's fine, good. So this is a formula, remember it. Now students, I'll be launching a concept test. Are you ready, everyone? Concept test. Concept test, students. So here we go. Are you ready for the challenge? You have to solve this question in 2 minutes. Fastest students will be, I'll see who is the champion, the fastest and the accurate answer. Everyone is ready? All the 10 students? Crystal clear? Okay, cool. So I'm showing you, you have to apply everything which you studied till now from today's beginning, not the initial lectures. Okay. 1, 2, 3, go. This is the question. Solve yourself. Try to solve it, students. Okay. 2 degrees. Excellent. JNV Shimla students have founded the answer. You are right, students. 2 degrees the answer. Now I'll solve it. See, this question says, find the minimum deviation caused by the prism having prism angle 4 degree, refractive index 3 by 2. Very simple. We know this thing that, what that? Simple. We know minimum angle of deviation formula is now, we've found it out this. Apply this thing. Angle of prism is given to you 4 degree. Refractive index mu is given to you 3 by 2. What's the remaining thing? So let us see the solution. See, this formula we applied, it's same as this, no? Answer is 2 degree, which is the final answer. How many students got this answer? Please reply in the chat box. How many of you got this answer? Please reply in the chat box. I'm waiting for your solutions. Okay, please reply in the chat box if you got it. Okay, you got this answer? Very good. Udampur students, good. Now let us see one more question. This also you have to solve. Okay. It says the picture is same. You have to find del minimum, that is the angle of minimum deviation, minimum angle of deviation, and also the I which is responsible for such minimum angle of deviation. I mean, you have to find such an angle of incidence with which if the incident ray is projected on the surface of the prism, and when it comes out as an emergent ray, the angle of deviation shown is minimum angle of deviation. You have to find two things here: this minimum angle of deviation plus such I, which is responsible for such minimum angle of deviation. All the values are given. Read the question and chat. Put a text in the chat box. You answer. You answer. I'm waiting. 2 minutes. One minute remaining, students. 1 minute. Okay. So your answer is 45 degree. Okay, we'll see. Genvi Roper students. There is an IIT in the Roper also. So how good it will be, if you get that college only. Sometimes it happens. People who are very studious and they got like some of the branch there. Maybe you people having the quota also. Okay. In state kind of case, some people in same area. Okay, 45 degree. I is what? Achha, I is 45 degree. Cool. See, I'm solving it here. I'm showing you the solutions. First, I will solve. Then for writing the solution, I'll give you the printed version. Janvi Shimla says 45 and of INC. First, I'm giving the solution here. Okay. See, let us directly find the minimum angle of deviation. We know it is mu minus 1 into angle of prism. Solving. You know, minimum deviation is mu minus 1 already given of this prism. 60 degree, because if you see the question, it's 60 degree. From this, you get 30 degree as the minimum angle of deviation. Okay, JNV Chandigarh students are also present. Excellent. Very good. Okay, very good. So we say here 30 degree is the minimum angle of deviation. Fine. We want the incident angle which is responsible for such minimum angle of deviation. How we'll find? We also know this thing. Angle of prism is equals to R1 plus R2, and in this case it is equals to A equals to 2R. Okay. And if I apply the Snell's law here, I'll say, if I'm applying the Snell's law here, students, I will say, what I'll say N1, which is air, sine of angle of incidence, because I need to find this I know. N2 glass, sine of R, which is basically from this equation. First equation is equals to what? R kitna aega? Because Snell's law is what? N1 sine I equals to N2 sine R for this surface. First, where the incident ray is striking, R will be equals to A by 2 from the first equation. Angle of prism is already given 60 degree. Hai. Angle of prism is already given to you what? 60 60 degree. 60 by 2. We get sine r as 3 by 2 into sine. Okay? So from this you can say angle of incidence which is responsible for such angle of deviation is sine inverse 3 by 4, which is the right answer. And angle of deviation is 30 degree. Okay? Now this is solved. Is it clear? Students, is it clear? Yes or no? Reply in the chat box. So I can show you the printed solution so that you can write in the notebooks. Okay, cool. So see, same thing we have done, and we got our answer as this. I equals to sine inverse 3 by 4. Write the solution. Okay, right. Okay, generally Monday student. If you have written the text in the chat book, if you have written all this. Okay, nothing I need to tell you here. There's one trick here. We know this thing. I have to remove one of the slides here. No need. See, we know this thing, angle of deviation is I plus E minus A. For minimum angle, for this minimum, इसको minimum बनाने के लिए we know I must be equals to E, single angle, है ना? So I'll put here 2I because I equals to 2A minus A. Minimum angle deviation, I know it's how much? 30 degree I got. I want this I can find from this also. It's 60 degree. So you will get the angle from this. Okay, so this is also a trick here. Remember it. Okay. I hope it's clear. Okay, let us not waste time. Move towards the next. Dispersion of light. We already knew the dispersion. Many times we have seen. Okay. A white light which disperses into 7 colors is dispersion. Simple. Okay, let us. I'm going to launch a video here. We'll understand some mathematics behind this dispersion of light. Okay, so watch the video carefully. See, we can observe this thing as I'm increasing the wavelength from the violet to the red color. This light color is changing, plus its deviation, emergent ray deviation is changing. If I see the white light, you can see a pattern VIGYAN. So I'll conclude that if this is normal, violet ka angle of deviation is this. Red ka angle of deviation, it's not angle of deviation, I'm sorry, it's emergent angle. If the normal is this, violet ka angle of emergent is this. Red ka angle of emergent is this for red and violet. Okay. So violet ka angle of emergence is, we'll say what it is, greater than the red's angle. Okay. So from here I will comment like this, that lambda for red is, it's greater than the violet. But the reverse is true. That is, emergent of the violet, emergence angle of the violet will be greater than the emergent angle of the red. Okay. So from here we can make a mathematical law here like this. Lambda is inversely proportional to emergent angle. Okay. Let us see the video again and conclude one more time. See it carefully. So if I'm increasing lambda ka EV tha, if I increase, it will soon reach to red, that is having the longest wavelength. Now see the emergent angle, how much it is? It's ER. Okay. So as you increase the lambda, emergence angle decreases. As you increase the lambda, emergence angle decreases. Fine, students? Please reply in the chat box. Okay. So now let us see one more mathematics which is based on this. There is some equation known as Cauchy's equation. It's founded from there, Cauchy's equation. It says refractive index is directly proportional to 1 upon lambda square or inversely proportional to lambda square. It means if you increase the lambda, it will get increased automatically by multiple times, that is twice, not twice, but multiples of it, due to which there will be decrement in the refractive index with a huge big amount. Because you are just increasing lambda by 1, but it's getting decreased by lambda square. So your refractive index will be get decreased by great amount. Why? Because it's opposite, inversely proportional. Now we know this thing already, that lambda of the red, that is from the electromagnetic spectrum, red ka lambda is greater than the violet ka lambda. Also we know that by using this equation, we can say, since refractive index is inversely proportional to lambda, violet of this violet color ka refractive index in the medium will be, like we'll say like this, refractive index for the violet will be greater than the red. So if we talk about the minimum angle of deviation, simple it is, apply the laws. So minimum angle of deviation for the violet will be greater than the minimum angle of deviation for the red, for the same kind of materials of the prism. If it's glass, still with a change in color, I will say angle of violet will be greater than this red. Okay, remember this. Students, is this thing clear? Please reply in the chat box so we can proceed next. Very simplified things I've given here. It's been automatically given here. Are you ready for the next? Reply back. Yes or no? Okay, yes. Note it down. So we can proceed next now. Any one of you, please reply. Right. Be comfortable, write it. Every one of you must write in the notes. Okay, JB Shimla, JB Mandi students. Everyone is important here. Okay, Chandigarh students. Fine. I hope it's clear. Okay. Now let us see some natural phenomena due to sunlight. Students, we are not going into the depths of this. Fastly, we'll see the optical instruments after this. Okay. So see what is happening here. See, you have most of the times you have observed this thing. A rainbow appears just after the rain. Just when rain is going to end, and sun, your back is up to the sun. I mean, you're standing in such a direction that sun is at your back, or your back is to the sun. So rainbow will appear in front of you. So let us see the video here. Okay. So watch the video carefully. This is the natural phenomenon in ray optics. So as your back is to the sun, you can see the rainbow is appearing. Okay, let me explain you. See, what happens? The water droplets, or the water, the water in the vapor from whatever, okay, the water droplets in the air, okay, it behaves like a triangular prism. This behaves like a triangular prism. And when the white light from the sun is entering this triangular prism, it shows dispersion into 7 colors like this. Okay. And when it is entering into our eyes, dispersion due to various water droplets will enter into our eyes like this. Okay. And this will be showing us a rainbow thing. Okay. I hope it's clear now. So it will show a rainbow because water droplets are behaving like triangular prism, and a white sunlight entering will show dispersion by this water droplet as a prism. And many of the water droplets in a series will show you many of such dispersions, and rainbow will be appearing when your back is to the sun. Okay. Now let us see somewhat about scattering. See, we know this thing in the atmosphere, there are many particles, water droplets, and many things. Dust will be also present there. Dust will be also there. So when a light strikes the dust, it scatters into different sticks. Also, you have seen in your room, when the sunlight is entering via some jolly kind of thing, it shows you how the particles are present in the sun and that sunlight. I mean, how many dust is there in the room, So it happens basically when the white light, basically the sunlight, passes through an imperfect medium. It's getting deflected off its straight path and scatters in many directions. Okay. It's the reason you see that bluish color of the water's color is what? If you take a simple water, no color, and sky color, if you go in the space, it's black. So from where the bluish color of the water and sky, from where it's coming, so you can explain through this scattering thing. Okay, that if we see the mathematics, we know for the diameter of particle less than the particular wavelength, say violet, indigo, red, any whatever. Okay, there is something known as religious scattering. It means if the lambda is greater, scattering will be very less, because if you just increase the lambda, it will get increased by lambda times of lambda times of lambda times 4 times, lambda raised to power 4. If you just do a little bit increment, it will increase by 4 times. 4 times, no, it will increase by multiple of 4 times of same itself. Scattering will decrease by multiple with multiple magnitude. So that's why in the spectra, violet is having the least wavelength. It is scattered the most. And red is having the longest wavelength. It is scattered the least. So visibility of violet is less than blue. Okay. Which is scattered more. How it will enter into your eyes? I mean, how you can see? If the thing is scattered more here and there, randomly, so the waves, how it will enter into your eyes. So if the things are entering into eyes, they must be in a proper direction. Okay. Next is this. Let us see the sunset. Why we're able to see during sunset red light? Why we're able to see during sunset red light? Anybody can answer? I'm waiting for your responses. Why we are able to see during sunset red light? Any one of you? Why we are able to see during sunset red light? I'm waiting for responses. You have studied this in 10th class. I want the complete. Anybody answer? Then I will explain. Okay. I want you to answer. Okay, I'm explaining. You see this. Very good, very good. So who answered this? Stolen students, very good. See, now I'll explain you the reason. Actually, we know this thing, violet is having the less wavelength. It is scattered the most, religious scattering. And red is having the highest wavelength and is scattered the least. But how we're able to see the red color? I mean, you see, blue color we must see, no? It's scattered, I mean, it's going in the random directions. And what's the reason? The reason is this, students. See, when the sun is at the overhead, the rays are entering like this. Suppose you are standing here. Suppose you are standing here. So when the sun is at the overhead, the rays are coming like this. You can see on your screens. Okay. And this is the gap between the earths on which we are standing and the atmosphere. So you can observe here carefully, students, that this is you. So this much distance this light has to travel when it enters in the atmosphere of the earth. Fine, this is a very less distance. But when sun is at the origin, so it is distance of the atmosphere through which the sunlight travels in the atmosphere. Okay. But when the sun is near the origin, it appears, see, it is appearing yellow, but it's perfect, it's white light. But now it's appearing somewhat orangish. Okay. It will appear to you somewhat reddish somewhere. Somewhere it will appear to you somewhere like, you know, some yellowish, some orangish. What's the reason? Because when sun is near origin, what happens? The sunlight enters like this. So now you can see here, total distance which it has to travel to reach us is very long, L, as compared to this small L. And we know the red color light is having the longest wavelength. Okay, so what happens among all the colors light, that is VIGYOR colors, violet and all these things, among all these colors, that violet, red, violet, indigo, blue, yellow, orange, red, okay, this top layer, yellow, orange, red, okay, they can travel the longer, because the wave is like this big, and violet will be short. Wavelength for particular one wavelength, it will be short, and it will be big. So it can travel through longer distances of the atmosphere. And somehow, okay, scattering, we know this thing. According to previous phenomenon, scattering of the violet will be more. But due to this atmosphere range, these are able to reach our eyes, and we're able to see it, the reddish color. Is it fine? See, it is actually the white light. No. Why appearing red? Because red is able to reach us. Via scattering also, there will be some least levels of scattering, but it's having the longer wavelength, which is compensating this thing. That is, it is able to reach into our eyes. Is it fine? Students, now you understood properly why the red is scattered and enters into our eyes. The scattered quality is less. I know this thing because religion shows 1 by lambda 4. Scattering is proportional or inversely proportional to lambda 4. It means red ka to least scattering hona chahiye. How is entering? Because it's compensated by this wavelength ranges. Because atmosphere is big, so red is able to reach somehow into our eyes, red, orangish, yellow. That's why at sunset we see this kind of picture. Okay, is it clear, students? Please reply in the chat box if it's clear. Please reply in the chat box, students, if it's clear. Clear or not? You're not replying. Okay, Shimla says clear. Solon student says it's clear. Okay, excellent. Very good. So, students, that was all about today's, yes, money students, it's clear. Very good. So, students, that was all about our today's class. Okay. Thank you so much for your attendance. I hope you understood everything. Let us conclude the last points. We will meet maybe in the next week. Okay. So we started with the prism. We have seen angle of prism. We have seen A equals to. Okay, Ludhiana students, very good. Shimla students, okay, thanks, no issues. So it's for you. Okay. We see this thing when we have also seen when there is angle of deviation, simple formula is this. Okay. We have seen for minimum angle of deviation, I equals to E minus A. And also we have seen a cool formula, basic formula is this. We have solved two numericals based on this. Simple, one was very simple, other was finding this I, which is responsible for the minimum angle of deviation. Then we have seen some natural phenomena. Based on this dispersion, scattering, and all these things. Okay. In the next class, students will start with the optical instruments. In the next class, we'll start with the optical instruments. Okay. So I'm launching a poll for you. Please, all of you, please participate in this NPS, and then you can leave. Bye bye, everyone. Take care. Study well. Be happy. So you're having few days remaining again for the next classes. Please participate in this NPS, and then you can leave. Okay. Take care. Study well. If you're having any doubt, you can reply. Bye bye, everyone. Take care. Study well, students. Bye, all of you students. Okay. Soon I will end it. Okay. Bye, all the YouTube students. Bye, everyone. You can reply in the chat box if you're facing any doubt here. Okay. How many students are remaining? Okay. Bye, Manoj. Chandigarh students. Bye, Solon students, and bye, Shimla students. Okay. Bye, bye, everyone. Take care. Study well. Refer HCV. You can also solve IE reader. Some questions, these are easy. Solutions are available. If you found out, you can text me there. Okay. Bye, everyone. Okay, I'm stopping.